Hi everyone, I'm Sehao Lin from MIT University. I will be presenting our CVPR work. The title is Knowledge Distillation by the Target-Aware Transformer. Let's start with some background. Knowledge distillation is a technique to improve the performance of small neural networks due to the discrepancy of learning capacity between the teacher and student. There is a long-standing problem for knowledge distillation called semantic mismatch. Here is an example. We can see that the teacher network has larger receptive field compared to the student network. This is because the teacher network has more layers. Thus, each pixel of the teacher feature map has richer semantic compared to the student feature map, which causes the problem of semantic mismatch. Previous work regressed the feature from teacher to student in the one-to-one spatial matching fashion, which may lead to suboptimal results due to the semantic mismatch. So how could we address this problem? We propose the one-to-all distillation, which allows each pixel of the teacher feature map to be distilled to all the spatial locations of the student feature map given the similarity. The similarity is generated from the target-aware transformer. Specifically, the target-aware transformer will measure the cross-attention between the teacher and the student, and the cross-attention will be used as the way for further distillation. Here is a more technical view of our framework. The target-aware transformer is the basic component of our method. It will first reconfigure the student feature by the cross-attention. Then it will minimize the L2 loss between the teacher feature and the student feature. For some real-world applications such as the semantic segmentation, the intermediate feature map may be large, and the computation burden of the cross-attention would be intractable. Thus, we further propose the hierarchical distillation. For the patch group distillation, it will divide the feature map into different groups of patches. For the anchor point distillation, it will summarize the whole feature map using the average pooling. Then they will be used for the subsequent distillation. Regarding the performance, let's first look at the image classification. We conducted experiments on CIFAR 100 and ImageNet. As we can see, our method can consistently outperform previous state-of-the-art. On the ImageNet, our method can outperform previous work even without the KD loss. We also extend our framework to semantic segmentation using the proposed hierarchical distillation. Again, our method can outperform previous state-of-the-art. And the ablation study shows that the patch group distillation is a little bit more helpful than the anchor point distillation. In order to understand the functionality and the behavior of the target-aware transformer, we visualize the feature map. As we can see, after the distillation, the feature map of our student model has a similar pattern with that of the teacher model. Regarding the TAT map, it shows that each pixel of the student feature map will aggregate the semantic from the neighbors to enhance itself. By doing so, the student feature can increase the matching capacity and alleviate the issue of semantic mismatch. Alright, this brings to the end of the video. Thank you.